Hey everyone, I'm Lingjiao. I am a CS PhD student at Stanford University. I'm working with Matilda Zaharia and James Doe, and more recently I'm been working on the machine learning as a service market, and more specifically, language language model as a service marketplace. I drink coffee a little bit, and typically just go to Starbucks and buy a tall latte there.
Yo, welcome back to another MLOps community podcast. I am your host, Dimitri Os, and what a conversation today. Let's go over a few of the key points that we were talking about because, wow, Lingjiao is spot on. I've been a fan since I saw Frugal ML, but then he came out with Frugal GPT, and we go so far into that paper, he basically walks me through each part, and I had to sit there and stop him a few times and say, wait, am I understanding this correctly? That there's this, there's that, all of the fun stuff and the technical implementations of Frugal GPT, he goes through and he does it with so much patience for me, the one who was struggling on a few of these concepts to really understand it. Hope you all enjoy it. And for those who are wondering who Lingjiao is, he is working with Mate. I first got tipped off to him because when Mate, the founder of Databricks, for all those who do not know, you like how we're on first name basis now, Mate Zaharia, he came on the podcast, and after he came on our podcast, I asked him, so who are some people that I should be interviewing besides you and everyone at Databricks? And he mentioned Frugal GPT. Well, he mentioned at that time it was only Frugal ML, but about a month later, he came out with Frugal GPT. And since then, he has also come out with a paper that stirred up quite a bit of controversy talking about how ChatGPT and GPT-4 have been getting worse over time. It's something that we've all been feeling and we've all intuitively thought, but they put some numbers around it and they released a paper and it caused quite a bit of stir. So yes, this is that author. Let's dive into it with him, the Stanford PhD candidate. And before we do, here is a quick word from our sponsors, QuantumBlack. All right, listeners, I have the pleasure of announcing right now with you that the MLOps community and QuantumBlack, the AI branch of McKinsey & Company, have partnered up. And for this special partnership, I brought on Nayur Khan. Your official title is partner, but your unofficial title is professional data nerd. Nayur, what exactly is QuantumBlack?
Really great to be here. Let me start briefly and say, our origins. We started off in Formula One. We realized early on that we could use data and AI in very smart ways off the track to have big impact on track times. And as I know, we took that mentality of using data and AI in very smart ways, help companies and industries on their toughest AI use cases, really using AI to drive impact. And we've done this across a whole myriad of different industries. I've mentioned Formula One and sports, but there's also natural resources, health and life sciences, consumer, and so on and so forth. We're about 2,000 colleagues globally in 40 different countries, and we have a whole host of different types of skills and technologies. Data science, data engineering, as you know, but also DevOps, software engineers, product design, SRE, cloud. So we bring and fuse all these different types of talent all together.
I had the pleasure of going and meeting you in person about a year and a half ago, and I went to the QuantumBlack office in London, and I loved it there because you set up a nice little Lego welcoming mat for me that said MLOps, and we also had some whiteboarding sessions, and you blew my mind with some of the projects that you are working on internally. Can you tell us a little bit about what makes QuantumBlack special and that vibe that I felt when I was there?
So I think, we are part of McKinsey & Company, but one of the things that we've maintained as QB is try to keep our culture. And there's two different things. It's our always learning type of mindset and being very curious about the problem, but also curious about the solution. There's a lot of great technology and solutions out there, but there's also a lot of white space that hasn't been solved. And I think our teams really get down and really are happy trying to drive through solutions with that. The second is this fun aspect. You mentioned Lego, and Lego is part of our DNA and really doing things in new and creative ways. I think this is really not only with the organizations we work with is very energizing, but also our people. They really dig this way of working.
incredible. So if anyone wants to go deeper down the rabbit hole and learn more about what you all are doing at QuantumBlack, we're going to leave a link in the description. QuantumBlack is always on the lookout for incredible talent. So if you think you fit the bill, we'll also leave a link for you to contact them. Thank you, Nayur, for coming and joining us. Let's get back to the show. Lingjiao, today I am super excited to talk to you, man, because I've been reading not only Frugal ML, but I read your Frugal GPT paper that you put out recently. And I know we were organizing this podcast when you were in the throes of putting that paper out. And then I saw that you put it out. You said, oh yeah, I got something really happening in May, so maybe we could do this in June. And then in May, I think you put out the paper, or April, you put it out. And I absolutely loved it. I know we're going to get really deep into it today. And you're going to explain to me all the pieces that I didn't quite understand, because it's a pretty beefy academic paper. And I just thought it was so useful, considering so many people talk about cost when it comes to large language models. And Frugal GPT is an awesome way to think about costs and think about how you can save money. But before we get into that, man, I think we should just start off with saying that you're currently doing a lot of amazing work at Stanford. You're working with Mate, who's a friend of the pod. He's come on here. And I want to hear your story. Like, how did you get to be doing all this research at Stanford?
Thank you, Demetrius. I'm super happy to be here talking with you. I'm also very glad that you like the FrugalGPT paper. So we should definitely go over the paper in the next few minutes. What is the first question? How did I come into Stanford? I think I was super lucky. I didn't start as a CS major when I was an undergrad, but then I went to University of Wisconsin to do a master there. I was focusing on databases and then apply for a PhD program, and Mate was very kind to get me accepted. So yeah, it's just I was super lucky. I got help from a lot of amazing people, and they're nice. They're very smart, full of wisdom, and just give me a lot of help. I was so grateful to all those people.
All right. So what's the day-to-day like in your research, and what draws you towards more industry-specific topics? Because I know there's a lot of cutting-edge research out there that is really trying to optimize things that aren't necessarily useful when it comes to actually using these LLMs in the wild. But it feels like you have your eye on things that can be useful in the real world. And that's not a dig at other researchers. It's just more of like, I see what you're doing and I see it as something that tends to have a different dimension.
I think one nice part about being in a university or being at academia is that you have the freedom to pursue whatever you like. So I think people could have totally different opinions on what to do or what is a good direction to pursue. Personally, I do have the intention to work on things that could be practically useful. That's actually part of my research principle. Like if you ask me, Lingjiao, what do you want to work in the next few years, right? I would say I want to work on things that are mathematically profound, but also practically useful, so that other people would be able to benefit from this kind of research. It's just, I feel super nice when I see, people could benefit from this work, or they could, get something from this paper. That's just my personal take.
Excellent. Yeah, I'm not going to lie, man. I think you may be the first researcher that we actually have on here, like practicing researcher. We've had a lot of ex-researchers that have crossed over and gone into academia, or into the industry. But I think you're the first one that we've had that's writing papers and doing academia full time. And it is because of these things that you're talking about, like you're thinking about how to make an impact on the industry, not just the academic world. So let's jump into this idea of the research that you're doing and go a little bit deeper onto like one thing that you told me before we hit record, which is that you do research on inventing data management inspired abstractions. What does that even mean? It sounds very cool, but I'm not sure I totally understand it.
Yeah, that's a fantastic question. So I probably could start by giving a little bit of background, right? Like I mentioned, I actually started doing research when I was a master, and there I actually focused on like, database related stuff. That's pretty much data management research. So what that basically means is that you want to process your data in user-friendly and system-friendly way. And their typical focus is like, you're doing, some transaction processing or some analytical processing there, right? So that's a great experience. I love that experience. But after doing that, I realized that, there is actually a lot of a connection between that data management community and the ML community. More specifically, the very core part of both like data management and machine learning is the data itself. If you think about this ML world, we have like fancy ML algorithm, we have great, hardware optimized for those ML workload, but without data, we couldn't do anything, right? So the main focus is really on data, and data management is kind of the same thing, right? Like we have those fancy tools, but the key is the data. We want to actually process this data, and by processing, it's like we want to get some insights from this data, right? So I think there's a big connection between data management and machine learning, which is the data part. How do we deal with the data in an efficient and user-friendly way? So I think that's kind of the key motivation. Like we want to see, hey, data management is there for a couple of years. It has the same focus as ML people have. So now, what's a good way, right, to bridge those two parts? Yeah. And why would I want to do that? But like, what is a data management abstraction or systems or algorithm, right? What does that even mean? What it means is that in ML world, you don't have to always view your research or the whole community as, hey, we're inventing new algorithms to process data, or we're inventing, new hardware or systems to make it faster. Another way to view it, right, is to say, hey, we actually have tons of data and we want to get insight out of it. Yeah. And how do we do that in a nice way? And that's data management, right? So I think data management is basically an aspect, an angle to view this machine learning research, machine learning engineering, machine learning deployment. It's just like a different way, a different angle of data management. And there we can actually draw a lot of insights from data management community. For instance, what's a good way to manage your data, to organize your data, so that it fit into the machine learning workload much better, like hopefully, right? Or if you view those ML workload as a data workload, what particular similarity or what particular connection you could see from data management and then use that to help you.
If I'm understanding this correctly, you are agnostic on the type of data. It doesn't matter if it's structured, unstructured, whatever complex data as can be called. You're just saying what are better ways that we can manage any type of data. And you're also a little bit agnostic on the approach to managing it too. Is that what I'm hearing is like, we don't necessarily need to say that just because it's been done like this in the past, that's the best way that we do it.
Yep. Yeah. One thing I want to add is that database or data management, by definition, is data type agnostic. Like it is definitely true that a lot of the well-known database data management research is focused on relational data or like tabular data, right? And you're pretty much familiar with, the traditional SQL language to process those relational data set. So that's absolutely right. But actually, even at the very beginning, the data management community view view data as like any types of data. Like that, you could deal with, say, relational data. You could also deal with graph data. And there, like when we actually have, say, image or video or audio, like multi-median data, or they call it objective database, right? Or objective relational database, right? So what I want to say is that, like database was typically viewed as saying, oh, it's dealing with relational tabular data, but actually it has a much broader scope.
100%. So then you were getting into Frugal GPT and how this was a perfect example of what you were talking about.
I think there's a very interesting connection between like Frugal ML, Frugal GPT kind of thing to the data management or database community. One other angle is that all those Frugal GPT, Frugal ML work is focused on the cloud ML as a service marketplace, right? Like all those giant companies like OpenAI, AI21, Microsoft, right? They provide those ML service as a cloud service, right? It's a part of the cloud. But the data management community already say like cloud, computing, like, cloud for big data, like 20 years ago, right? Like while we're not inventing, the sky kind of stuff, there was actually a notion, right, after cloud computing, the sky computing, right? People are saying, hey, you have a bunch of clouds, and now we could augment the sky on top of that, right? Let's try to abstract the whole cloud into a sky so that people don't need to worry about the internal details of all those cloud services, cloud computing. They can only operate on the top abstraction. So for Frugal ML or Frugal GPT, it's very similar, like in spirit, right? You don't need to worry about the details of those cloud ML providers services. You can just operate on top of that. So in that sense, you see that's kind of the sky ML thing. So basically, it's like, in data management, we have cloud data, cloud computing. Now people say, hey, we can build sky as an abstraction to handle that. And in Frugal ML, we say, hey, you have this cloud services, cloud ML. Now we can actually build another abstraction to operate on top of that. So that's kind of a very similar, right? Another aspect to look at is like, there's a big trend in the data community to think about what you can do with the data marketplace, right? So there's a huge interest in buying and selling data. Right. And it's the same thing, right? Like what is data? Is data necessarily, relational stuff, or could data also be the predictions produced by ML service? And we actually also draw inspiration from that aspect. Like if data doesn't have to be, relational tabular data, if it could also be ML predictions, then what you can do with that, like data market.
Yeah.
Right. In that sense, like ML market, like cloud ML services, it's just another version of data market.
Whoa, wait a minute. Let me see if I'm understanding this correctly. You're basically saying, hey, these APIs from OpenAI or whatever, Anthropic, you name it, they are just another data provider in a way. It's like a data marketplace, and you're using OpenAI as one of the data marketplace providers.
Yep. That's one way to think about like those ML services.
So instead of leaning heavily on, okay, this is going to be the be all to end all, and I'm going to just do everything through OpenAI, it's like, no, OpenAI is going to be one of my data streams and one of my providers, but then I also have 10 other ones that I'm using, and I can then build some kind of abstraction on top of that.
Yep.
Dude, okay, now I'm starting to see more. Okay, so we should probably break down what Frugal GPT is, and also maybe break down what Frugal ML is, because we may have put the cart before the horse. And so anybody who hasn't read FrugalGPT paper, this is my understanding. And you tell me if my understanding is correct and where I'm getting it a little bit lost. But what you're doing, and I love the idea of having these 3 different circles in a Venn diagram. And so that made it very easy for me to understand, basically. If someone is making, let's say someone wants to interact with a model or a large language model for that case, you're saving that person money because you're doing 3 different things before and after and during the interaction with the large language models. And so the first thing is you're running some algorithm or something to make sure that the prompt is fully optimized so that the prompt is not using unnecessary amounts of tokens and not spending unnecessary amounts of money. So that's the first thing. It's like, how can we fully optimize this prompt to make sure that it is running at the most efficient way? So we'll put a pin in that because I want to ask you questions about how you do that exactly, but let me just explain the whole thing before we go back to that part. Then the second piece is, all right, now that we have this optimized prompt, we're going to see if we can fulfill the questions that are being asked through open source models first, because those are cheaper and you don't have to pay per token and hit the API. And especially if you get to a certain scale, it may become unreasonable. And so you see how much of the question or the task can be serviced by these open source models. And then if there is a delta between what you need done and what the open source model can get to, then you say, all right, now we're going to go to these APIs and we're going to say, out of all the APIs, let's figure out which one, and this is where I think, and correct me if I'm wrong, this is where the Frugal ML comes in, where you say, out of all the APIs, we're going to use machine learning and AI to go and figure out what the cheapest model API call is going to be here. And so we say, all right, cool. This one, whatever, OpenAI is going to be the cheapest for this query. We're going to use OpenAI. Or actually, Claude is going to be the cheapest, so let's go and use that. So that's my understanding of it. And it's almost like you said, it's an abstraction layer on top of all of that, so that if you are trying to interact or get something done, you can save money because it goes through all these nets and it's able to optimize your query. And then it's able to say, all right, let's see how much we can do with open source. And then if you can't get it all done from open source, or you can't get anything done from open source, it goes to an API, but it makes sure that the API that it calls is the cheapest and most reasonable price due to the prediction from the machine learning model. What else? What did I miss?
I think the very high-level understanding is super precise.
Yes, that's what I'm talking about.
Super precise.
But tell me, all right, now that's high level, but now let's go low level.
I think you probably missed the third part of the FrugalGPT paper. So you basically mentioned the first two, right? How to deal with the language models prompt, how to deal with the multiple service providers. There's another little part about how to approximate those large language models. Like one of the key things there is that there could be a lot of redundancy among your queries, and you could actually use some system techniques or ideas, say caching, to deal with that. Like for instance, right, if you use LLMs for, say, a search engine, right, or to support your customer service, from the user's perspective, your process queries could be quite similar, or there could be a large scale in your query distribution at some point, right? Say, let's say it's a election season, and there are a lot of queries about elections for models, and they're pretty much asking the same thing, right? And then you don't have to ask a language model multiple times the same question. You can actually ask it once or a few times, store it locally, and whenever you need it, you can reuse it. So I think that's another missing part from your understanding, but that's totally okay. Like I think this first two part are pretty close.
Yeah, that's a huge cost saver. That is very true, because at the end of the day, if people are asking the same question over and over, you don't need to ask the LLM over and over. So if you have something which is probably a very popular use case for LLMs, it's like that chat with your data type use case. And so whatever your data is, you slap a vector store together with an LLM and you have a chat with your data. It's very easy to get up and running. I think even that's like one of the most, it's like the hello world of working with LLMs in a way. So you're doing that, and that is like the first piece then I understand. And so from there, if you say, all right, first we're going to just check and see if we have the answer cached, because then we don't even need to go through the whole mess of trying to figure out if this needs to go through an LLM. And then if it's not cached, then it's like, okay, now we go down the rabbit hole and we go deeper down the rabbit hole of what I was explaining earlier.
Yep.
Okay, cool. Makes 100% sense. And now what I want to know is when we're talking about that first step of optimizing the prompts, how do you do that?
Yeah, that's a great point. So first of all, I want to say, like, there always exists more than one solution to any, in my opinion, to any research questions, right? So I don't want to say, hey, we exhausted all possible answers. No, I just want to give like few examples so that we kind of see like what are some reasonable and feasible ways, right? Okay, so going back to your point, I think there are a lot of ways to optimize the prompt. One interesting idea is to do certain query concatenation to minimize or to reduce size of prompt. So what that means is that you take two or a few queries and compress them into a large one, and then send this large query to the large language model, so that you can actually allow those two queries to share some similar part in the prompt, and therefore reduce the size of it. Okay,
Wait.
I guess I'm making it too complicated.
No. I follow you. So if I'm understanding it correctly, the thing that I guess I'm not understanding is that, all right, so you're taking two different queries and you're saying there's some overlap here. It's not the same question, so it's not going to hit that vector store caching model, but there is some overlap here, and we're expecting the output to be kind of similar, or we're expecting the output to have overlap. So why don't we put these two prompts together and then send them as one prompt?
That's correct, but I was actually thinking about something even simpler.
Oh, all right. That's even better. I like that.
I guess it's probably easier if I show you one page on a slide, so you kind of see
sure.
what that.
Show us what you got. And for those that are listening, I'll make sure to describe what I'm seeing on the slide so that they can understand.
Hey everyone, my name is Aparna, founder of Arise, and the best way to stay up to date with MLOps is by subscribing to this podcast.
All right, sweet. So we got that sorted out. We are now looking at a slide, and there's all kinds of crazy math or what looks like prompts, questions, answers. What are we seeing on here?
Yeah, I would say it's not really math, but we do have some symbols there. Right. So I want to use this slide to show how one of the particular prompt optimization, the query concatenation, works. So it's actually pretty straightforward. So let's say you have two queries, right? Like one query is what's the result of end-to-end output at high temperature, you also have another query, what helps pre-high, and you want to add a few in context example to those queries, right? To help the LLMs think about what's the right answer. So let's say you have like 4 in context examples appended to each of those questions.
And this is just so the listeners understand what we're looking at is we've got a layer that is like a prompt layer, and it says like Q1 plus A1, comma, Q2 plus A2, comma, Q3 plus A3, comma, Q4 plus A4. And those, then right under that, we've got a layer that says a question, which is what you mentioned earlier. What is the result of N2 and O2 at high temperatures? N2 and O2, I am guessing, are like the good old periodic table we're talking. That's what we're referencing here, like nitrous or not. I can't remember my chemistry class, but N2 is one of those, and then O2, I guess, is oxygen.
Oxygen,
and yeah. So, and then right under that, directly under that, we've got the same kind of thing where there's a prompt Q1 plus A1, comma, Q2 plus A2, et cetera, and then directly under that is the question, what helps prey hide? And both of those, you're smashing into, so all 4 of those things, or just the prompt, you're smashing into the query concatenator.
Right.
And the query concatenator is what you were talking about, where you take both of those and you put them together.
Right. We put those 2 questions together, and we compress the in context example. So the new prompt only contains Q1 plus Q2, A1 plus A2, Q3 plus Q4, A3 plus A4 only once, right? So now you can actually compare the new query and the old query, right? In the old query, to process those 2 questions, you need the LLMs to process the in-context examples twice, right? Because you have 2 questions.
Okay, so if I'm understanding this, basically, what you're saying is the money saving comes in because the prompt, which is the Q1 plus A1, Q2 plus A2, that kind of thing, you're only doing once. And then you're throwing in these different questions with those prompts, and you're seeing the output, and the output is going to distinctly have like a clear line as to where the question 1 and the question 2 are isolated. There's no blend in those 2 answers, I guess, is my biggest question, is like, doesn't GPT, and so for people listening too, so basically it goes in, these 2 things go into the query concatenator, and you're left with a sandwich of, well, not quite a sandwich. So it goes into the concatenator, and you're left with the prompt, just one layer of the prompt of the Q1 plus Q2. And then you have both of these questions together, and then it goes into GPT-4. And then the output is 2 circles where you have Q1 answer, and then you have Q2 answer. And so my biggest question is, doesn't Q1 answer and Q2 answer get blurred?
No, it won't get blurred, because you could add you could add certain identifier, right? So one way to add it, right? So you could write, like, you could format your prompt in a way such that the output would be something like answer, and then a note 2, and then answer conflag, or like answer 1, note 2, and answer 2, blah blah blah. So this answer 1, answer 2 would be the identifier that separate those 2 answers.
So my biggest question is, aren't the 2 answers going to blend? And you're saying no, because you can do specific things to make sure that doesn't happen?
Yeah, so the basic idea, or the basic approach, right, is to add some identifier to separate the 2 answers.
Oh, of course. you just ask GPT to tell us what the first answer is and tell us what the second answer is. All right, cool. We're back a day later. I'm in different clothes. You're in different clothes because I had a little problem yesterday with my internet, but I'm not going to let anything stop me from learning from you. It's not going to happen, man. So back to this slide that you're showing on the screen. I had the day to think about what exactly it was that you were saying to me, and I totally understand it now. So basically, when you're economizing the prompts, what you're doing is you're saying, we've got these two questions. They're completely different questions, right? Like you can see on the slide here, you can see that there's a question about chemistry, and then you also have a question about nature and what helps prey hide, et cetera, et cetera. And what you're doing is before each one of these, if they were their own prompts, then you would give a question and answer kind of like few shot description to the model saying, hey, here's what I want you to do. Here's the question one and answer it like this. And then question two, answer two, et cetera, et cetera. And then you give it question, which is the chemistry question. But you say, look, you know what? We don't even need to do two different prompts because we can just smash these two questions together and ask the large language model at the same time. All right. And say, well, here's question one, here's question two looks like, here's question, and actually what I see in this slide is even better, and I didn't even recognize this yesterday, but you have question one and question two together, and then you have answer one and answer two. So you're pairing the questions so that the model isn't thrown off when you give it two questions and ask it for two answers. And it all makes sense now. I totally understand it, and hopefully the listeners do too. And if they don't, then I'm going to encourage them to go and look at the YouTube video because you can see the slide clearly and you can really get an idea of what's going on.
Yeah. Thank you so much for explaining the whole thing.
I mean, that's awesome because the big question that I had yesterday, I remember, was like, how can you tell? Like, I couldn't see how the model would not blend the answers. But now I easily see it because the prompts that you're giving it are questions and answers in pairs. So then the prompt that you give it is, or the last question answer pair, you just say like, here, answer these last two questions, and boom, then you have it. And so back to the $1 million question, which is, how does this actually save money?
Right, that's a great point. So why would this save money, right? You can basically compare the original two queries or two questions versus the new question we have, right? So in the previous version, we have those two queries. You need to process those two questions as well as the prompts twice, right? But now in this like batch or this concatenated query, you only need to process the prompt once, right? So therefore, you actually avoid redundant prompt processing, and that saves you the money.
And have you tried, like, how much can you push this? Can you do it with two questions? Can you do it with 10 question pairs? Like, how far did you try and go?
Right. So so far we tried to push this to up to 4 questions. So that, roughly speaking, saves you about 70% of the cost, which also does not hurt your accuracy. So that's what we try so far. And I think in general, this could be pushed to much further, depending on the maximum prompt size. So for instance, if you're using like standard GPT-4 with like 80,000 token window size, and if each of your queries like a few hundred, they can push this to a 20, 40, or even 80 examples. So that can save you a lot.
Yeah.
Okay, it makes complete sense. All right, so now this is awesome. If I wanted to go about implementing this, how do you recommend it? Like, what is a way that I can start doing this now with my prompts? Is it just looking at, hey, where do I have similar questions? Where do I have similar prompts that I can use? Or is there some kind of programmatic way to do that?
Not yet, but we will release the code for Frugal GPT in a few days, so then people can directly.
No way. So by the time this is out, by the time this podcast is out, it will be out. So we'll leave a link in the description then. And I'm
Yeah,
sure.
I hope so.
Yeah.
Oh, let's be out.
Yeah, exactly. And so then next is you're going to go make the rounds and raise a couple $100 million, and it's straight to the moon.
Yeah. We should do that, right, guys?
So, okay. So interesting to hear then. Right now it's kind of manual, just looking at where can you crunch these prompts together and how can you be more economical with your prompts. But you do have something that you're going to release that will help people do that. And I feel like there was another way. So this was one way of economizing the prompts. There was more ways though, right?
Absolutely.
Give me all of it. Tell me everything.
This one might be the most interesting and also very different from the one we just see.
Mm-hmm.
Right? So far we have been saying, okay, you have one service or one language model, right? You wanna play with the prompt, you wanna concatenate different queries, get better results. Now we can take a very different angle, right? So let's say you do have that fixed query or prompt, but you have the ability to leverage all available LLMs on the market,
Mm-hmm.
right? So if that is the case, how could you actually possibly save money from that marketplace? So one deep insight there, well, maybe not deep, but one interesting insight is that there's a large performance and cost difference among those language models. So therefore, you could actually build a large language model cascade to adaptively select like which language model to use for your own application. So in this example, right, you can think of this cascade as a sequence of LLM APIs or service. And when you have a new query, you pass that query to the models in this sequence sequentially. And whenever one model says, this is the answer, and you believe that's a high quality answer, you stop there, you return the answer, and you never need to query any remaining service. Otherwise, you keep querying the service in the sequence until they reach the last one and return the answer there. So in this example, right, we have a cascade that consists of three services, GPT-J, GPT-3, and GPT-4, and the cost of them also grows in its sequence. Mm-hmm. And you pass the first query to GPT-J, GPT give you an answer, but you think the answer is probably not good enough, right? So then you pass the query to the second one, say GPT-3, and GPT-3 gives you another answer, and look at the answer, you say, okay, this is probably the right answer. So I will stop there and then return the answer. So now there's no need to query GPT-4. Right? So that avoids, calling the expensive GPT-4 model. So the hard part or the interesting part here is how do you actually know whether an answer produced by, say, GPT or other model is high quality or is good enough, right?
You're reading my mind.
That's where the machine learning or the AI technique comes in, right? We basically build a AI model that takes the query and the answer from, say, GPT-J or GPT-3 as input and generate a score that measures the quality of the generation. And then, you can tune a score threshold to determine, hey, if you think this answer is high quality or low quality. And you can do all of those things automatically without, human manipulation or inspiration. So that's kind of the main idea, like automate the whole scoring and cascade and a cascade building process.
Dude, this is one of the things that a lot of people were very excited about when I posted this paper in Slack. Originally was the idea of the cascade method. And I didn't realize that you were using another model to score it. I just thought, I understood the cascading part where it's like, hey, first start with an open source model. If that doesn't work, go to a cheaper model like the ChatGPT or GPT-3. Then if that doesn't work, then go to the expensive one, because obviously not all queries are going to need GPT-4 level answers. And that is very clear. And GPT-4 is the most expensive, so your price can really get out of hand if you're always using GPT-4. However, I stopped there at my understanding. I didn't realize that it makes complete sense, because as you were explaining this, I was thinking to myself, okay, so what? I'm going to have to validate each output, and then if I don't like it, I send it back, or I click a button, no, give me a better one. But if you're using a model to score it, and then if it gets above a certain score and it's acceptable, then you serve that up to the end user. That's awesome. That's perfect.
Yeah, I'm glad you like it.
I'm your biggest fan, dude. I don't know if you realize that by now. I'm going to be...
Thank you so much. You're my first fan. I would really appreciate that if I become a star,
Exactly. I'm going to get your autograph.
Yeah.
Before you become famous.
So that signature, I can give you one right now.
There we go. Oh, that's classic. That is good. Yeah, but so one thing I did want to ask you about the cascade method is, when you were messing around with this, did you also ping around to different APIs? Like right here, you're just talking about GPT and basically the OpenAI APIs, but were you also looking at, okay, how can we cost compare with Anthropic or Cohere or whatever else is out there? Oh, you got a slide for it. All right, here we go. I know it's real if you got a slide. Here we go.
Yeah, it is there. I guess it's probably not that friendly for a podcast because there's so many slides. But I guess I got your point, and I think the answer is yes. We do look at a bunch of APIs from different providers. So those providers are, first, there are a lot of providers here. There's OpenAI, there's AI21, Cohere. So we measure the APIs from all those providers for a few different data sets. This is just one example. So in the cascade, you see 3 of them because we want to save the cost for the users, right? So let's say there are 20 APIs or 30 APIs in the market, and you include all of them in your cascade, right? Then that itself could be very expensive for a user, right? Imagine for every query you have to, pass through, all the 5 or 6 cheap APIs. That's not a quite desired, right? So what we actually did is that we can include all those APIs in the market as candidate APIs and build a optimization framework to select which APIs should be included in the cascade for different users' application or data.
Wait, so...
Right, so that's why it's the 3.
So, okay. If I'm understanding it correctly, then you're using different APIs based on the different inputs that you're giving, right? And you're only doing 3. 3 is the max, because otherwise it just doesn't make sense. You're not saving money. You're probably spending more money.
Yeah. Actually, you could use even more. Yeah, we actually tried a few options. We tried 2, tried 3, tried 4. So generally speaking, the more you have, the better like prediction quality or generation quality you have, but the higher the cost you need to pay. So yeah, like 3 is a kind of a sweet spot, but 4 or 5 could also work.
So biggest thing that jumps out at me on this slide right here is that accuracy for the DALL-E model is basically the lowest that it can get. And Mate is your advisor. He let you publish this?
Yeah. Well, we use the Databricks serving system to serve the DALL-E model here. So you can see, yeah, like the accuracy is probably not as good as the other model, but that's also released as part of DALL-E's earlier paper or blog post. They say that, hey, DALL-E was not developed to be the state-of-the-art model there, right? But you can see the cost is much smaller than GPT-4.
Yeah, it's so low. That's so true. Oh, man. So it's interesting to me, too, that GPT-Neo is so high in the accuracy. And that's a model that's been out for a long time. And wow. I mean, then you go and it's like GPT-Neo, GPT-3, J1. I'm not sure what the J1 is.
J1 was model 21.
Okay, cool.
Yeah, I probably should have these stats somewhere saying, oh, this model from this company, that's that company.
Yep, it makes sense. Okay, so interesting. So basically, just bringing this back to the end user, and if I'm at my company and I want to try and do something like this, is there, like, how can I get started and try and implement this? Or is it even worth it unless I'm racking up millions in API calls?
Yeah, we'll also include this in the upcoming code release.
Investors are going to be hanging early. Yeah.
Yeah, there's just a few work just a little bit more work to make the code easily accessible. That's why we spend so much time there. But yeah, I promise that the code will be released in a few days. Then people can directly use that to help with their own applications.
I love it. Yeah, I love it. So, all right, then this is again on that cascading piece. There was another piece that you had, and maybe we can go over one more before we finish it off.
There's another piece that's called large language model approximation, right? Like that one basically is about how you could approximate the performance of large language model using much cheaper infrastructures or simpler technique. So I actually want to go over like one very simple but in my opinion useful technique. So that's as simple as storing and reusing LLM's answer for similar queries. The key idea, right, is to add a cache layer on top of the large language model. And whenever you send a query to the language model, you first send that to the cache and to say if there's any query you already processed before that's very similar to this new query. And if so, you use that answer from your cache. No need to query any large language models. Otherwise, you go to the language model, you get an answer, and then send it back to your cache. Right, so it's just as simple as that. But I want to make 2 points here. First, this is quite useful when you have like similar queries. For instance, if you have a search engine powered by LLMs and users are asking the similar questions at a certain time period, you can avoid sending all user queries to a language model. So that's kind of quite a common application right now. Second point I want to make is that there's a lot of interesting research and also practical questions to consider, even for such a simple architectures. For instance, what's a good way to design the cache policy, right? Like your cache, like if your cache is huge or like has infinite memory, then there's no problem. But typically you have a fixed bandwidth with your cache. Maybe it's like, just a few gigabyte or something, right? And if you have a lot of queries, at some point, you need to decide which query to keep in the cache and which query to move out of the cache, right? So how to design good caching policy, that's a one big problem. And second, you need to sort of have a way to determine, hey, if this query is similar to queries in my database or in a cache, but how similar is similar, right? How similar is similar? I give one simple example, right? So you could have two questions that are like very similar grammarly or like superficially, but the meaning is totally opposite, right? Like what if I ask what is outcome of N2 and O2 at a high temperature? And I could also ask what is not the outcome of O2 and N2 at high temperature, right? So those two queries could look similar, but their semantic meanings are quite different. So how do you actually identify the similarity there in a systematic way, right? So all I'm trying to say is that this looks simple, but there's a great opportunity to make it robust and efficient, and also there's a lot of application of this.
Yeah, it's like there still is, because the idea of using a vector store is probably one of the most common design patterns these days when you're working with LLMs, I think. And so you cache the query in a vector store maybe, and then you hit the vector store before you go to the LLM. But there are all of these really tricky situations where you, like you said, the query may look similar, but the answer is the exact opposite of what the other query would be. And so I know there's a lot of pain points or just big questions out there when working with vector stores. What's the best practice and how to do that, how to go about it. So that's awesome. This is some good stuff. I mean, have you seen best practices, and are there some quick tips and tricks that or you came across while you were doing it?
I think actually application dependent.
Oh, interesting.
Yeah.
How so? Like,
I don't think there's any like good and principled solution yet. That's not to my knowledge. I think there are like a few tricks that you could use for certain cases. For instance, if like for the negation example I talked about, you can manually insert that as a rule, right, in your MetaDB, or just add another layer on top of that. But I don't think so far there's any principled way. Yeah, that's kind of good thing from a research perspective, because there's a lot of research you can do.
Lots of open area. Yeah, totally.
Yeah, but I guess it's a pain for users.
Yeah, exactly. But I mean, hopefully it won't be after a while. One big question that I have is, do you use any of these together? Like, are you using for example, this caching layer with cascading and maybe another one? Or is it, if you use one, you kind of have to stick to that one, and then you don't want to veer too far out?
Yeah, there are actually a lot of composition ideas or composition methods. I can give like a few of them. For instance, this caching idea could be easily composed with the LLM Cascade, right? So you could have a joint cache that store the prediction or generation for all the services in your cascade, right? And whenever you query, the similar question, you look at the cache and say, oh, it's already processed by the previous model, or it is already processed by some other service before. You can actually fetch it clear, and there's no need to query anything on the Cascade anymore. So this could also be composed with a query concatenation thing, right? Because you can just cache everything from that batch query as well. You can also combine the LLM Cascade with the query concatenation, right? Because you can say, okay, I view all of my queries as a batch query, right? You say you have 1,000 queries, you first concatenate them into 500.
And then you cascade them.
Right, then you cascade it. Right. So yeah, like there's a lot of ways to combine or to compose all those things.
Oh, that is so cool, man. Well, dude, this has been awesome. I think you have been feeling how excited I am for what you're doing. And I think there's a lot of people out there that are using large language models that definitely feel the burn of using the large language models, and it can get quite expensive, especially if you're at scale. And so these tips and tricks on how to bring that cost down is super helpful. And so I thank you for that. And I am very excited for the tool that you come out with, and we'll make sure to highlight it in the description, and I'll probably try and throw it in the newsletter. So, man,
I appreciate that.
Yeah, this conversation has been great.
Yeah, it's all my pleasure. Like it's really nice to talk with you. And thank you so much for helping me explain a lot of things. It's way better than my own words.
It's just to make sure that I understand it. I want to because since I have you here, it's not every day that I get to actually talk to the author, and basically it's talk to your PDF, but in real form, and you can explain it to me much better than any large language model can. So I appreciate that, and I love the work that you're doing, and I think we can end the pod here, man.
Oh yeah, sure. Thank you so much.
Hey, this is Mike Del Balso, co-founder and CEO of Tecton. MLOps community is the best way to stay in the loop on the latest MLOps news and best practices. It's also a great way to connect with experts and get support from an amazingly helpful community. Subscribe and stay in the loop.